So we are now going to look at breakdown of protein. So we are going to use albumin as our substrate, okay? It's a pretty common protein. It's basically egg white. And so we are going to put that in both the test tubes. And then we are going to add this enzyme pepsin, which helps with the breakdown of the protein. So I'm going to add deionized water to one as a control, and I'm going to add the pepsin to this one, but it's in the stomach. The pH of stomach is between 1 and 2. So it will not work in something that's just made with albumin and water at a pH 7. So I need to lower the pH. And for that, I'm going to use hydrochloric acid. Oops. Hydrochloric acid for that. Okay? Sorry, completely forgot. All right, so I'm going to add albumin to both of them, about 2 centimeters. Okay, so this is P1. I'm going to add deionized water to this one, 2 centimeters of deionized water. And this is P2, and I'm going to add the enzyme and the pH lowering agent. So the enzyme is pepsin. You find pepsin in your stomach. And in the stomach, you also have hydrochloric acid to keep the pH low. And here is hydrochloric acid. Okay. Now I will put parafilm on them and shake them.
Shake it down.
Okay. Okay. Parafilm on this one. And then shake it. Okay. Now we will take these 2 test tubes and put them in 37-degree bath. 37 degrees Celsius is our body temperature, and so we are going to put it in there.
Hold on. Chuck, do you want me to hold this frame and let her come back into that frame?
Go ahead.
Okay.
Yeah. Okay, so you got her on.
So we're going to put these 2 test tubes in the 37-degree bath. And I have 2 exactly same test tubes that I did an hour ago. Oops, sorry. And I am putting them in here. So I have my P1 with water, and I have my P2 with the enzyme and hydrochloric acid. Now we are going to look for protein. Now, of course, there is protein here because my substrate was protein. And enzymes are also protein. So we are going to get protein. But what we are going to do is we are going to do bioret. And if there is protein, it will turn violet. But if the peptide bonds between the amino acids break, because our goal is to take the big protein and break it down into smaller ones. So if the peptide bonds break, that reaction of breaking off the peptide bonds will turn the reagent from dark blue to kind of pinkish purple. So violet means protein but no breakdown. Pinkish purple means broken down protein. Okay? So now I'm going to add those. Ow, ow. 10 drops. Okay, so there is a very subtle color change. Hang on, there's a very subtle color change. So what I'm going to do is hold a white paper behind it so that when we zoom in, you can actually see there is a slight difference in the purpleness of it.
Then I understand with it a little bit.
Yeah, can you zoom in for me more?
So this is the one where there was no breakdown, and this is the one where we did have breakdown. And if you look carefully, there is a very slight difference in the color. This looks more violet, and this looks more pinkish. It has a pinkish tinge to it. And if we left it there longer with more enzyme, it would probably become a little bit more pink because there would be more breakage of the peptide bonds. Okay, so this shows you with enzyme and the correct pH, that's why we added the HCl, with enzyme and the correct pH, the protein started to break down. Without the enzyme, the protein did not break down. So that was the protein breakdown.